Hey y'all, hope you're having a good day. Full disclosure, I do not have my webcam up right now because I'm home doing my lecture and Finn's in here with me. So if you hear any crazy little 4-year-old in the background, I apologize, but I hope you can get this. I'm trying to get this done so you guys can get it as well. So we are on the brain part 2 of your notes. This is the second lecture of the week. Just to let you know, remind you that your assignments due this week is nervous system worksheets 3 and 4, and that you need to make sure you are studying for your tests because we're going to have a review next week that's going to be kind of big over this. So just make sure you're keeping your notes at home. I do not want them. So that way you have them as a study aid whenever you get your review for next week. So let's go ahead and get through these pretty quickly. I'm going to go pretty fast just because I'm home with Finn. So the thalamus, remember we've already talked about the lobes. So we're going to be talking about the inner brain today, especially the midbrain, the pons, thalamus, hypothalamus, all of that, because that is really where all the information is sorted from your peripheral nervous system up from to your central nervous system through your spine. So let's talk about the thalamus. The thalamus is the two bulb-shaped halves in the center of the brain. You can see it both on the side view, and you can see it also on the inner view. And you can see that you have two sides on both the left hemisphere and the right hemisphere. It relays sensory impulses to the cerebral cortex for processing and sorting. So all of your sensory things that happen, it's going to come here to the thalamus, and then it's going to sort it out where it needs to go from there. Remember, down here is where our pituitary glands are, and we're going to be talking about that. So just kind of be looking at the diagrams and getting familiar with those. Hypothalamus. Hypothalamus simply means below the thalamus. It's a tiny portion of the brain near the thalamus. And this is where it controls the pituitary gland, which you can see right here, posterior and anterior pituitary gland. Remember that your pituitary gland is in charge of a lot of involuntary actions, such as your body temperature, hunger, thirst, sleep, and blood volume. So then we move on to the brain stem. The brain stem is located between the cerebellum and the spinal cord. Oh, we've gone through this. Okay, midbrain. Midbrain. Also known as mesocephalon. It relies information to the cerebrum. It controls body movements and posture. So my question to you is, if it controls body movements and posture, what lobe does it specifically work with? Lobe or lobes does it specifically work with? I want you to drop that answer in the comments below. The pons. The pons is this bulb area right here, and pons is basically just means a bridge. It is almost made of white matter that links the cerebral cortex to the cerebellum. So it's what bridges the gap between both of the sides of the hemisphere, and it carries information from one side to the other. It is also your central control for breathing. So we know that a lot of times if your spinal cord is damaged during a accident, sometimes it has to do with motor skills, but also if it's damaged higher up for brain damage, it can directly affect the pons, which is likely going to be fatal. Medulla oblongata, my favorite word. It's located just above the spinal cord. It transmits its impulses between the spinal cord and the brain. So think about as your medulla oblongata as your first entrance of your neurons to enter your brain from the spinal cord and the peripheral nervous system. It's going to travel up. It's going to take those impulses and it's going to sort it to where it first needs to go so that the next person can do their job and the next person can do their job. Sorry, Finn's in the background. It controls blood pressure, heart rate, swallowing, and coughing. Cerebellum, we've already gone through, so we're just going to skip right over that and move on to the spinal cord. So as you can see on the spinal cord, it is this long line right down all your vertebrae, even to your coccyx, okay? From there, you have your peripheral nervous system, which is all of these other nerves that's spreading out along your body that controls your senses. They all work together. It extends from the medulla oblongata up here. Remember that first gate. And it consists of 31 pairs of spinal nerves branch out from the spinal cord connecting to all the parts of the body. It relays impulses from the peripheral nervous system to the brain. And a cross section of the spinal cord has a butterfly of gray matter surrounded by white matter. I want you to think about why that is so important. So in the last lecture, I wanted you to look up the difference between gray matter and white matter, and they both work together. But remember, the gray matter is where those neuron cell bodies are. Remember what the dendrite looks like. That big gulp in the middle is those neuron cell bodies, okay? And white matter is the specific containing myelinated axon. So your gray matter is made of the nerve body. The myelin axons is what is the impulses, the nodes of Ranvier that is connecting to other neurons or sending the action out through the body. So it is when it says it's a cross section of spinal cord, of butterfly, of gray matter surrounded by white matter, that means that gray matter in the middle, right here, is taking out that information and sending the impulses down all of the axons and neurons that's inside of that. Let's talk about our reflexes real quick. A reflex arc is caused by a stimulus transmitted to the spinal cord by a sensory nerve, then back to the muscles through a motor nerve without first being transmitted to the brain. There's two examples I want to bring up. First is when you were a kid, they checked your reflexes with the little hammer that you can see in this illustration to the right. And it is an example that the sensory neuron and the motor neuron work together in creating a reflex so it doesn't go all the way to the brain to be sorted to know what to do with that reflex. It is automatic. That is where the difference of the gray matter and the white matter come into play, is that one is telling it what to do and it doesn't have to go all the way to the brain to transmit that information. The second example is our fight or flight status. If someone jumps out and scares me, a reflex for me is going to jump or scream. That is the motor neuron acting with the burst of hormones that just has happened to cause me to be scared. Okay. And it doesn't go all the way to my brain all the time. It is an automatic reflex. It can happen in many different ways. Sometimes whenever we have somebody tickle the middle of our knee, we call that, the Charlie horse tickle, we might automatically jerk our knee. That's a reflex as well. So let's talk about common diseases of the nervous system. And as I go through these, I just want you guys to write a few notes on each one of them. I may be asking you some of this in your test. So just having a few ideas of what each thing is. So cerebral palsy is a disease of the nervous system that is usually found in birth, and it affects your motor system most of the time. Okay, so there's differences in severity. Some are wheelchair bound, some have mental handicaps, some do not. Some have muscle tone problems and posture but can still walk. So cerebral palsy is usually found even before they are born. And there's different risk factors, but it can affect vision, it can affect hearing, and it can affect intellectual disability, stiff muscles, controlled balance. It just depends on how severe the cerebral palsy is. Coma, what is a coma? That's basically when your brain is sleeping. It's still working, but it's sleeping. It can happen for several different reasons: stroke, heart attack, any of those things, altered state of consciousness, trauma can induce a coma. Encephalitis. This is going to be a little bit different from hydrocephalitis, which is what we'll talk about in a minute. So encephalitis is the inflammation of the brain, often due to an infection, and sometimes it's bacterial or viral, like meningitis. Some of the symptoms include headache, vision problems, It can also can be cured if it's treated correctly. Some causes can be or symptoms can be seizures or weakness, but it is treatable. Epilepsy, that is a seizure-based nervous system disease. And it is when you have a sensory disturbance or loss of consciousness or convulsions. And it's because there's abnormal electrical activity. So your neurons, if you have epilepsy, your neurons are not working properly. Headache, we know what a headache is, brain pain. Hydrocephalus. So hydrocephalus is also swelling of the brain, and it can be caused for many different reasons. You know that cerebral spinal fluid is what keeps the pressure of up against from causing abrasions on our skull from our skull. So if extra fluid is put on the brain and can cause brain damage, but most of the time they are found out to have this in birth. They may have an extra large head, they may have impaired vision, their eyes may look down, they may have cognitive disabilities or difficulties or loss of concentration. Mental illness is when we have a chemical imbalance in the brain that can cause depression, anxiety, suicidal thoughts, so forth. Meningitis is can be both like encephalitis, can be viral or bacterial. One of the symptoms is a stiff neck. You can have in like a headache. You can have your spinal cord feels like you basically feel like your head may fall off because you're stiff neck. Multiple sclerosis. A lot of you guys did your little essay from the lymphatic system on multiple sclerosis. So instead of me telling you what that is, if you wrote your paper on that, which several of you did, I want you to write 2 or 3 sentences of what multiple sclerosis is in our comments. Parkinson's disease. Parkinson's disease is most commonly found in people over 60 years old. It is when our midbrain kind of starts disappearing. It can cause lesions on the brain. It can cause severe shaking. It can cause hallucinations, and it can cause even dementia and Parkinson's sometimes go hand in hand because of the lesions on the brain. It's usually slowly at first. You start noticing small tremors. Sorry, guys, had a cough. Small tremors, but then you can also start having slow movement and balance difficulties, stiffness of limbs, not being able to walk. Phobia is also a disease of the nervous system, just being scared of different things. Senility is usually affected with Parkinson's or dementia or Alzheimer's. Um, Usually it's just when there's a mental deterioration because of age. They lose memory, they lose a sense of what reality is or awareness is, and it's because it's affecting this different parts of the lobes of the brain. And then shock. Shock is usually a disease resulting in trauma. So that's where we're going to end today. Just a reminder to turn in your worksheets this week, and we will get ready for our test next week. Of course, if you have any questions, you are welcome to email me or text me. Love you guys. Talk to you later.